Good day, everyone. Thank you for joining today's Docker webinar. A few housekeeping items before we get started. As a reminder, the session is being recorded and a copy of the recording will be sent out to you a few days after the webinar. We will take questions at the end, so please post them in the Q&A window located in the bottom right of your screen, and our speakers will address them at the end of the session. I would like to introduce today's speaker, Andrew Weiss, Lead Federal Sales Engineer at Docker, Aidan Feldman, Innovation Specialist and Developer at 18F, and Greg Elin, Founder and CEO of GovReady. I will now turn this over to Andrew.
Thanks, Melanie. Go ahead and get the screen going. Excellent. So as Melanie said, today we're going to talk about compliance and how Docker interacts with the compliance process for federal IT compliance needs. Namely, we're going to talk about the ATO process in general. And if you're not familiar with the ATO process, or authority to operate for short, we're going to go over just the ATO process at a high level. We have a fantastic set of speakers today. We've got Aidan from 18F who's going to talk a little bit more about what they're doing within GSA to address some of the challenges and potential shortcomings of the ATO process. And then we're also going to show you how at Docker we're using some cool technologies to help you automate and streamline your compliance processes today. But first, one of the things we want to talk about, if you're not familiar with the Federal IT Modernization Report to the President that was dropped in draft a few weeks back and will soon be released, there's a lot of really good content in here that talks about IT modernization specific to the security and compliance processes. And there were a lot of great public comments submitted from various vendors, including ourselves at Docker, where we talked and all these folks talked about how the ATO process in general, compliance processes in general, could certainly use its own modernization process as well. So if you look at the approaches that a number of agencies take today to go through compliance and to put together IT systems, it's a little bit antiquated. And while every agency does things a little bit differently, the process is pretty much the same. We have to assess a system that we deploy. We have to ensure that we've selected a certain set of security criteria that the system meets. And ultimately, we have to go through an arduous paperwork exercise that oftentimes derails some of the innovative efforts that agencies are after as far as adopting new technologies, modernizing legacy systems, and so forth. So if you haven't gone through this report, there's a really good section on there. There's a lot of great comments on there, rather, that talk about how the compliance processes in general could also be modernized. And we hope to see some information about that once the report is finalized. But one of the things we want to talk about first is FISMA. FISMA is really at the heart of federal compliance requirements today. If you're not familiar with FISMA, FISMA has been around since the FISMA Act of 2002, short for Federal Information Security Management Act. This is essentially the quote-unquote holy grail for IT systems today amongst federal government agencies and the path they take to deploy these systems. And really at a high level, and we're going to try to keep things at a high level as we go through this, it's really just a set of requirements that are enacted by law that require agencies to ensure that their IT systems are deployed and meet certain security criteria and ensure that they're protecting citizen data and confidential data appropriately. So really it's comprised of a set of governing bodies and organizations that define the frameworks or mandate the policies or require specific pieces of the system to ensure that the system is met to adherence to those pieces. So one of the core pieces of FISMA, for example, is NIST Special Publication 853. This is really the core set of security controls and the core standard that which most federal agencies are familiar with today and by which they're deploying systems to ensure that it meets these controls. This is a pretty robust catalog of controls, a few hundred of them, and it actually was just updated recently. The current available rendition is revision 4, but revision 5 also just got released in draft. And it covers some of the more modern IT system workflows today, so Internet of Things, mobile device endpoints, and so forth. And then there's also this notion of RMF, or Risk Management Framework, which we'll talk about in the next slide. So we've got FSMA, we've got the security controls and standards, and then we also have the Office of Management and Budget, or OMB for short, that provides oversight and mandated policies by which agencies have to adhere to actually ensure that their systems are meeting these requirements. Then, of course, FSMA consists of some sort of categorization mechanism. So when an agency deploys an IT system, per FIPS 199, the system has to be categorized depending on the type of data that it's interacting with. And these are known as low, moderate, high, which oftentimes translate to the baseline by which the system has to be authorized as well. And then, of course, an agency will go through a typical risk assessment process, and then ultimately put together the primary document that describes the system and ensures that the system meets those requirements, and that's the System Security Plan, or SSP for short. If you've gone through this process personally, if you're a contractor supporting an agency, or you're working for an agency and you've gone through the ATO process, you probably know that the SSP is this long, oftentimes 1,000+ page document that's hard to maintain. It's typically a Word document that doesn't really do a good job itself evolving as the system evolves. And this whole process makes it difficult to adopt new technologies and so forth. And then the final step, of course, is we have to continuously monitor the system. Oftentimes FSMA is pretty much applicable to every IT system before it is placed in operation. And many of us know that this is a lengthy and time-consuming process. So if you are familiar with FSMA, apologize for kind of the high-level overview, but this just kind of sets a baseline that most agencies from a generalistic standpoint go through as far as federal information security. So let's talk about risk management framework, and this is actually timely as well because the next revision of this was also just released, and it also encompasses some more modern ways of looking at IT systems and so forth. Risk management framework has been around for quite some time as well, and it really goes hand in hand with FSMA. It's a piece of FSMA that describes the process that I just went through at a high level, where an agency has to categorize a system, select the controls from a catalog. Most often, this is 853, a catalog of controls. Ultimately, we have to implement those controls in some capacity or another, and every agency does this a little bit differently. Various agencies will add additional controls on top and so forth. Then, of course, we have to assess these controls against the actual system itself. We authorize the system and put together that SSP documentation, and alongside that, we have POAMs, or Plan of Action and Milestones documents as well. And then we go through this continuous monitoring phase. This has been a tried and true mechanism that's recently been updated. Really does a good job and is aligned pretty closely with the cybersecurity framework as well that hits on every IT system. I'm not sure if we have Greg on yet from GovReady, but he's got some pretty cool facts around RMF, where even though the actual framework was written some time ago, over a decade ago, and it predates a lot of cloud technologies and infrastructure as code mechanisms that we have today, it's still applicable to a lot of the approaches agencies take to actually deploy compliant systems. And this framework is being used outside of the federal space as well by a number of private entities and commercial corporations. So where does Docker fit into this whole model? And we get a lot of questions when we meet with various federal agencies as far as deploying Docker into their environments. Docker is really just like any other information system. So we have FSMA, which mandates these requirements. We have the set of controls and the catalog, and categorization mechanisms through FIPS 199 and so forth. And then ultimately, the agencies have to go through their own ATO process with Docker, just like any other information system. And this diagram here is a great little diagram from the FedRAMP Program Management Office over with the GSA that kind of hits on this whole process at a high level that talks about what I was just talking about. And then, of course, a lot of agencies today are grappling with this notion of FedRAMP. This FedRAMP program has been around for quite some time as well. And this is a requirement by which cloud service providers, or any providers that are offering hosted or managed services to federal agencies today, have to meet not only the NIST 853 requirements and categorize the systems themselves, but also additional security requirements that are enforced by the FedRAMP Program Management Office in coordination with various CIOs from various governing bodies as well, so across DoD, DHS, and GSA. Also, OMB has mandated the use of FedRAMP accredited services by federal agencies. So any agencies today that aren't using FedRAMP accredited services have to justify as such on a quarterly basis. So one of the other questions that we get a lot in the Docker world is where does Docker fit in FedRAMP? How does Docker interact with FedRAMP? Well, Docker itself, the enterprise engine and the community engine as well, is really just a piece of software. It's a service that runs on a virtual machine or a physical host. So as far as FedRAMP is concerned, FedRAMP is focused on cloud service providers. And while we, Docker, do have some cloud-hosted services, so if you look at Docker Store and Docker Hub and Docker Cloud, our primary focus today is on the actual service or the enterprise engine itself and the software that runs in an approved system. So really, Docker can sit on any FedRAMP accredited provider today, namely in the realm of FedRAMP accredited infrastructure as a service provider. So any cloud provider like AWS, GovCloud, or Azure Government, or CSRA's, RP2 Cloud, any number of clouds that are included within the FedRAMP marketplace that are accredited, that provide virtual machine hosting services and so forth, can host Docker EE components that are either managed by the agencies or also managed by the cloud service providers themselves. So there are a number of cloud service providers that have deployed container offerings as well. And while some of these aren't yet included in their existing FedRAMP scoped boundary, we wouldn't be surprised if those services would be available at some point in that boundary. So you have a lot of different ways that you can consume Docker under the FedRAMP umbrella. And to further clarify this, we're simply adding another layer here in the policy framework. And where does Docker fit? Again, Docker is simply a piece of software that sits on top of these requirements. It's something that an agency still has to ATO and still has to go through the authority to operate process to approve. Albeit, when you're running Docker on a FedRAMP accredited provider, you can inherit additional controls underneath, so you no longer have to worry about some of those underlying infrastructure security controls that you'd be focused on. And with Docker, for any application containers, you can inherit even more controls, and we'll talk about that in a future slide. So, like I said, Docker is just a component within an information system. It has to be ATO'd and authorized just like any other piece of the stack, and that includes all of its dependencies as well. So when we deploy Docker, when an agency deploys Docker today, we have to categorize the usage of Docker, so whether or not it's processing low, moderate, or high, impacting security data. We have to assess the risk for the use of Docker. We have to authorize, and of course, we have to continually monitor it. At a high level, most agencies today have to receive some sort of ATO for quote-unquote go live or production deployment for Docker. That hasn't prevented most agencies today from actually deploying Docker, getting started in their environments, and then of course they go through the ATO process from the get-go, and then over time they can expand their environments by way of authorization cycles and so forth. And then also there are a number of agencies today that have approved software listings. So most agencies require not only a system to be ATO, but also approved and tracked via their own IT asset management approaches. One such example is the VA today, where they've publicly posted a number of their approved pieces of software and those versions of software, and this varies by agencies. As many of us know today, the ATO process is really specific to an agency, and even furthermore is specific to a specific system within an agency. Sometimes there are agencies that will basically authorize a system multiple times, the same system, but it varies per the organization that's consuming that system. So if you have an organizational unit that may be using Docker in one place, and then you have another organizational unit using Docker in another, oftentimes that they'll require multiple ATOs, even for that same piece of technology under the hood. And then, of course, like I said in the previous slide, Docker can run on many FedRAMP accredited CSPs today, like Azure Government or AWS GovCloud and so forth. And while by inheriting the controls underneath and speeding up the ATO, many agencies still have to go through the process by which they'll ATO the entire cloud service provider by consuming the FedRAMP accredited documents as well. So let's start digging into Docker a little bit more and how it plays into the realm of ATOs and how agencies are actually approaching this today. So first I want to list off the current list of certifications that Docker adheres to and that are required either by NIST 853 or recommended or required by FedRAMP and so forth. So namely, the first one is the Docker Enterprise Stack is undergoing FIPS 140-2 Level 1 accreditation right now, and this is by way of the Cryptographic Module Validation Program for NIST. You can go through and get the status of this. We blogged about this recently. So all of the cryptography modules that are embedded within the Docker Enterprise Stack are currently in process and implementation under test per NIST CMVP. We're also working through Section 508 BPATs for accessibility requirements. A number of federal agencies require this today by law. And all of the UIs that are included within the Docker Enterprise Stack are undergoing this assessment today, and we'll have this available early next year. And these are specific to the Docker Trusted Registry and Universal Control Plane UI. So if you're not familiar with these pieces of the stack, these are the components that provide for centralized registry services and cluster orchestration capabilities as well. And then, of course, across the federal space, there are a number of ATOs at play today for Docker Enterprise Edition, and also some agencies that have ATO'd the community stack, albeit there's a little bit more work involved there. So from a high level, what does it take to actually get an ATO for the Docker Enterprise stack? And I'll caveat that this is a generalized list right here. Like I said earlier, every agency goes through a very different process, so this may not be exactly reminiscent of your agency and how you ATO a system. But at a high level, this is the approach that a number of agencies take today. So obviously, we have to complete some sort of system security plan, which describes the system, talks about the risk being assessed in the system. Again, we're talking, 1,000+ page documents, kind of an antiquated process, but this is the process that agencies go through today. Then, of course, we'll take this document, and an agency will submit it to internal audit teams to review it. That document would then be sent back to the system owners for further review, and this back and forth process proceeds until the ATO is ultimately granted by either a certain authorizing official. Oftentimes agencies require CIOs to sign off on these systems as well. And one of the challenges in this process is that many agency internal audit teams don't have a good set of knowledge about the technology being authorized itself. So in the world of Docker, this is the challenge that we face, where container technology is still a relatively new space to internal agency environments. So some of the work that we've been doing is to help educate agency audit teams as to what Docker is, how these things can be authorized, and so forth. And then oftentimes it still takes quite some bit of time to actually get an ATO for Docker. Now, like I said earlier, when you're running Docker on top of a FedRAMP approved or FedRAMP accredited provider, namely in the realm of infrastructure as a service, you can inherit a number of additional security controls underneath, which drastically improves the time at which you can actually get an ATO for the Docker stack itself. But also, like I said, agencies still typically require a quote-unquote agency-wide approval for that CSP. So even though they can consume the FedRAMP documents provided by that CSP, namely the CSP's SSP and so forth, it still takes a while for the agency's internal security teams to actually review that, which further slows down the review process. So talking about Docker a little bit more, where does Docker actually fit as part of the ATO boundary? And most agencies today are comfortable with this notion of virtual machines. It's been a technology that is well adopted across the federal government today, and most folks are familiar with the concept of a hypervisor, which provides for a virtual guest operating system and subsequently the applications and dependencies that are installed on that VM. And if we look at the right-hand side, and we can see that the ATO boundary today, as it exists in most federal environments, encompasses the guest operating system, bins, and the application itself. And again, this is specific to the application ATO boundary. Of course, there's another boundary where you'll have the actual infrastructure services, whether or not that infrastructure is hosted in-house by an agency or provided by a FedRAMP provider. We're going to ignore that for now, assuming that that is the case, and only focus on the application ATOs. Now, if we look at the left-hand side, you can see that the application ATO boundary is actually a little bit higher in the stack. And furthermore, with Docker and containers, we can actually start to inherit even more controls underneath and abstract away the operating system that would typically be included in an authority to operate boundary. So if you approach application ATOs rather than including the guest operating system in the full stack, and you simply only focus on what's included in the container itself, which is most oftentimes simply the binaries and libraries and the core application code needed to run, you can significantly reduce the time it takes to actually authorize a system and reuse many of the underlying security controls that have already been pre-allocated for you. So that includes either FedRAMP approved or FedRAMP accredited providers. Maybe you're hosting your own hypervisor stack that's already been authorized. And furthermore, I'm going to talk in a second about how you can even authorize the Docker engine itself and incorporate those controls as pre-written controls into your stack. So it goes to show you just the different boundaries between where does Docker fit, the container boundary for ATOs, and virtual machine ATO boundaries. And again, this is just a general high-level approach. Every agency approaches this very differently, but this is most often what we're seeing as the benefits of using container technology for improving the ATO process. So Docker, what are we doing to make it easier to get an ATO for Docker EE? We understand the challenges and the arduous paperwork exercise and the back and forth process between internal audit teams, and One of the things we're really focused on is helping agencies complete the ATO process faster for Docker AE, and not only doing so in a faster manner, but also using modern technologies to streamline the ATO such that we can be in a state, or an agency can be in a state of continuous compliance regardless of what application stacks they are running in those container environments. So rather than having to focus on the full stack for virtual machines and the full application dependencies, we can treat application ATOs in the realm of container technologies and reuse many of the controls underneath. So to make this whole process easier, what we've done is we've actually licensed, or we've actually open sourced the entirety of our ATO guidance, and we've published it all on GitHub. And furthermore, we've actually licensed this content under CC/0 1.0 Universal Public Domain. And what that means is we've essentially waived all the rights to this guidance, making it easier for federal agencies to consume this content and even contribute back where appropriate. And what's included with this guidance is a set of pre-written narratives for the Docker Enterprise stack. So all of the components that make up Docker. So you have the core container runtime, or the Docker engine. You have the Docker Trusted Registry, or the core centralized registry services for distribution of software internally for your agency. And then also the universal control plane stack for orchestration and centralized management. All of these components have been mapped to the applicable controls in the NIST 853 catalog. And rather than you as an agency or you as a consumer going through the ATO process yourself for Docker, we've pre-written all of those narratives for you, so you don't have to figure out which pieces of Docker map to those controls. Albeit, there are a number of security controls that are specific to the organization, so obviously we can't fill those in for you. But what we've also done is we've given you templates such that all you have to do is fill in those blanks and consume the controls that are already pre-allocated or pre-written by us. And how we do this is we use a set of tools that are built by the Open Control community, and we'll talk a little bit more about Open Control in a coming slide. And Aidan will talk a little bit about where that fits in the realm of their project, their really awesome Project Boise efforts within GSA. But what this allows us to do is allows you all to do is to take this content that's been pre-written, you can fill in the blanks with our templates, and then you can run it through these tools to auto-generate your SSP documentation. And furthermore, these tools themselves can also run in containers. So you can actually run the tools on the platform that which you're actually building your security documentation for. So you can essentially be in this state of continuous compliance. And you'll see that in a demo that I'll show shortly. We've also included some other handy tools as well that make it easier to actually validate the system against the running controls. So we've been playing around with Chef's InSpec open source auditing toolkit, which is a really cool toolkit that allows you to not actually configure your system such that it meets those controls, but rather audit the system against the controls that you've deemed as applicable to your environment. So we've included a couple of profiles for validating Docker against both the FedRAMP moderate and FedRAMP high baselines, and it allows you to not only create your security documentation, but actually check the running system against the controls at those various baselines. So at the end of the day, we are trying to help agencies treat compliance just like continuous integration and continuous deployment pipeline, just like the core value proposition for Docker and containers itself, and ultimately end up in this state of continuous compliance. So like I said, you can run the SSP tools in containers, the InSpec tooling for validation, and so forth. And we've also been starting to play with some pretty cool technologies around natural language processing that provide for some automated proofreading mechanisms in the actual security narratives themselves. So not only can you write the narratives, but you can automate the actual review process, which could enhance the back and forth that we see amongst ATO audit teams. And then also we're working through best practices, reference architecture for ATOs. So not only are we publishing the content out in the open, but we'll also give you step-by-step as to how you can consume this content and create ATO documentation amongst your own environment. And then we've also worked with the Microsoft team on the Azure side to provide a pre-written SSP template for Azure Government that covers all these Docker controls, and we're happy to share that out if there's interest. So I talked a little bit about control, but what exactly is this Open Control project? So Open Control is really just a set of tools and a core schema which allows you to automate compliance documentation. It's hosted on GitHub. It was originally the initial development was originally driven by some of the folks at 18F, including Aidan and his team. But there have been many other contributors, including ourselves, Pivotal, Red Hat, GovReady, and so forth. And it's essentially a compliance as code framework that allows you to simply generate your SSP documentation. But of course, it can be used to generate documentation for any number of compliance standards. So not just SSPs for FISMA requirements, but also security documentation for PCI DSS and so forth. How the documentation is put together is it uses simple YAML syntax. So if you're a security professional and auditor and you're not familiar with YAML, it is pretty easy to pick up, and it's actually a little bit more intuitive to work with than trying to dig through Word documents at scale. And with how it works is you can separate the system into a series of what are called components. So I talked a little bit about the components in Docker Enterprise. So you have the engine, Docker Trusted Registry, DTR, UCP, and so forth. And that's all we've done in our repository of controls here, where we've split up the Docker stack into a series of components and created separate YAML files. And these components allow you to map the, or these component files allow you to map the actual system pieces to the applicable controls in the 853 catalog. So for example, if control AC-2 dictates authentication and authorization requirements, well, we've described for you how Docker Enterprise meets those requirements by the built-in authentication and authorization stack that's provided, and here's how it meets that, and here's reference stock for that. And we've done that for all of the controls that are applicable at the NIST 853 high baseline. And again, OpenControl is used primarily to auto-generate SSP documentation. It's kind of an unofficial community initiative today. It's still maturing. We are an unofficial member of that initiative, but it's something that we're still committed to providing resources for and tooling around and enhancing over time. So that what I'll do is I'll show you a little bit of a demo of how that works. So first off, this is the open source repository that I talked about, where you can get all of this content today and all of the pre-written security control narratives for Docker Enterprise. So this is all against the current revision of 853. We've also documented these controls at the FedRAMP moderate and high baselines. So if you're an agency that's deploying Docker onto a FedRAMP existing provider, you may want to consume that same baseline still. Or if you're a CSP and you're authorizing some sort of managed service built on Docker EE, you can also consume these baselines. Let me show you what one of those YAML files looks like that I talked about. So if we click on the components directory here, I'm going to go through Docker Trusted Registry. So this is the component.yaml file where we've pre-allocated all the controls for you. So it talks about Docker Trusted Registry. Here's a general link to what DTR is. And then for all of the controls that are applicable, we've pre-written the narratives. So for control AC-2, bullet 1, we've said this implementation is complete per the Docker Enterprise stack at this layer. And we say that to assist the organization in meeting the requirements of its control, you can figure out how to manage users and teams per this documentation here. And like I said, we've repeated this for all of the applicable controls in the stack. Now, furthermore, what you can do is within this repository, you can combine the controls that we've pre-written for you with controls that you're going to define as an organization. So if I go through this example right here, and I actually have this in another window, and I'll show you how this works. In the policies directory, and this is an example project that you as an organization would use to generate your own controls, you can see that control AC, for example, it has its own component YAML file. And furthermore, there are template placeholders that for all of the applicable controls in this control family. So for AC-1, not only do I want to make sure Docker meets its control, but in this case, I want to define my agency's control implementation here. And this is set up for all of the different sub-bullets and so forth. Now, while there's still a lot of content that you have to fill in, we're now putting this content into a machine-readable format, which we could do a lot more with versus putting this content into a templatized Word doc that isn't as easily updatable and isn't as easily transferable to other IT systems. So with that being said, here are some of the cool things that we can do with that stack. So what I have here is a terminal session. So even if you're not a developer or you're not a techie geek, but more of a security audit professional, what I'm going to show you is how I can auto-generate my SSP documentation and serve this documentation as a website. Now, there's a number of different ways you can serve this documentation. Most folks are familiar with a Word doc, so you can certainly serve this documentation as a traditional Word doc or a PDF and what have you. So what I'm going to do is I'm just simply going to actually build my documentation. And if you noticed here, I'm actually using Docker to build my documentation. You'll see why this is even cooler in a second. And you'll also see that I'm serving this documentation locally on my machine. So if I go to my localhost right here, you'll see that I'm now serving a sample SSP that covers Docker Enterprise Edition per my specific agency, and we're going to assume that we're just a dummy agency here, but in your case, you would obviously fill in your requirements. So if I click on AC2, for example, I can see here's a description about the control. Oh, and here's how Docker Enterprise adheres to that control with a direct link to the documentation. And furthermore, I can see all of the blanks that I would have to fill in for my agency-specific requirements for access control policy AC-2. So for bullet A, here's what I would define here. For bullet B, and so forth. And you can see that this is a much easier to consume document right here, and it's actually a website that I can serve itself. And I can go through all the different controls. I can see at the bottom here direct links to the different components with direct references. And you can combine both the Docker components with maybe other components that you're using in the stack. So for Azure Virtual Machines, for example, or some other virtualized stack that you have in your environment where you'd want to install Docker on, you can combine those controls here as well. So let's also take this a step further. So what we can do is not only can we check to make sure we can generate documentation here, but one of the things that we can do is we can actually package up our documentation as a Docker container or Docker image, just like any other application that we deploy in our environment. So let me go ahead and connect to my trusted registry. And if you're not familiar with trusted registry, this is the centralized repository for Docker images that are deployed into a specific environment. So if I just type in SSP here, I should have SSP doc. Actually, I'm not sure the exact name of it that I put in. It'll be on the page here. Here we go. Docker EE Modern SSP. So you can see here that this is the repository for my Docker image that actually contains the prepackaged SSP as a web server. And you can see that I versioned it against the 17.06 version of Docker EE. Of course, I can add additional tags. It includes not just the documentation that I generated, but also an embedded web server, which adds a little bit of space to this. But now that I've packaged it up as a Docker image, I can take my SSP and I can ship it as a service, just like any other container that I'm deploying on my platform. And that's exactly what I've done here. So you can see here that I have an SSP service running on my Docker Universal Control Plane platform. I've orchestrated it, I've scheduled it just like any other application service. And furthermore, I can connect to that service, and this is a live URL, so you all can go to this URL if you're interested. And I can actually serve my SSP just like any other application on my stack. So if we recap, what we've done is we've taken machine-readable content. We've included all of the security narratives that define our system. We've containerized that content, and we've deployed that container just like any other application container on the stack. And what's even cooler is that this application container, which includes the compliance documentation, is the compliance documentation for the application system itself. So you can imagine reproducing this process for all of your other application containers that you've deployed. So maybe you've deployed .NET apps or Java applications, and you want to quickly get ATOs for all those application stacks. Well, you can simply regenerate and deploy your ATO documentation, fill in the blanks using those machine-readable formats, and deploy that right alongside your applications themselves. So you can ultimately be in a state of continuous compliance. So quickly, just going back to the slides here, what about for ATOs for containerized apps on top of Docker EE, which is what I was just talking about. So I'll just recap here from a high-level example, and then this is not specific to any agency or whatnot. This is just an example system. Let's pretend we're running Docker EE on a FedRAMP cloud provider like Azure Government. So we would install Docker EE on a number of infrastructure as a service VMs, which would sit in this stack here, and then we would include FedRAMP PATO for IS, so we include scope for that, which Microsoft has already done for us. And then what we can do is we can go through this exercise that I just showed to basically automatically develop and deploy our system ATO for Docker on that stack. And because we can inherit a number of underlying controls, there's a lot fewer action items that we have to take as a federal agency. And this diagram here on the right kind of shows the different cloud computing models and how they map to the control responsibilities based on where you're deploying. So this example, again, is specific to the Azure world, and this is actually from Microsoft. It's a pretty cool diagram that shows here are all the NIST 853 control families. And you can also see who manages what controls and where each of those cloud computing models fits into that stack. So if you see here from an infrastructure as a service perspective, so these are virtual machines provided by a cloud service provider, you can see that there are a number of physical controls that are provided by the data center or the managed services by Microsoft that Microsoft manages for you. So all of the physical data centers, networking, and so forth. If you take a look at platform as a service, so these are your hosted services, maybe like an Azure SQL or web apps and so forth, where Microsoft is even further up the stack with what they manage for you. Now, if we think about Docker EE sits here as this infrastructure as a service. So this would run on top of the OS and provide you with all of those application containers and so forth. So you can see clearly that you're inheriting a number of services provided by Microsoft. Now, in the right-hand column, you can also see the controls that are also pre-provided by Microsoft themselves. So if you look at physical environment controls, access controls, configuration management controls, all the way up the stack, you can start to see more clearly where Docker and infrastructure as a service maps to the pre-allocated and pre-written controls for you. And by including some of the documentation that we just showed on GitHub within this stack, you can further expedite application ATOs that reside in containers. And just to show you and prove to you that we're not just providing this to the masses, but we're actually consuming this content ourselves, we are actually auto-generating compliance content for docs.docker.com. So if you go to this URL, you can start to view the compliance content documentation that we manage right alongside our other open source documentation. And furthermore, we've also provided a quick reference for NIST 853, which basically talks about all of the pre-mapped controls for Docker and allows you to quickly reference where those controls fit and mount to the Docker enterprise stack. So even if you're not auto-generating SSP docs and you want to quickly see if a control meets or if Docker meets a certain controls requirements, you can do so on our website. Now with that, I want to turn it over to Aidan Feldman. Aidan's been doing some fantastic work over at 18F, and I want to let him talk about some Project Boise initiatives. I'm going to take that Docker hat off for a second and just talk about where ATOs kind of fit in the government model today, what's being done to maybe address this process, and to potentially further streamline this today. So Aidan, can you hear us?
Yes, I can. Thanks, Andrew.
Excellent.
All right. So yeah, my name's Aidan Feldman, and I'm an engineer at 18F, and I've been the lead for a project called Project Boise, which I will talk about in a second. So 18F, first of all, is a digital services team housed in the General Services Administration, or GSA, and we work to modernize technology in the federal government while improving the public's experience. We build a lot of software and therefore experience a lot of ATOs, and Project Boise is this vaguely codenamed project to understand how 18F can be most effective in improving the security compliance process. As you can see here, we hope to reduce the burden while also improving the effectiveness of these processes. So that pain can come in a lot of forms, specifically in time and cost, but also frustration. Our experience is that a lot of people going through security compliance processes are not compliance professionals, right? They're program managers and development teams, et cetera. And so this burden is placed on people who don't have any experience reading, understanding, or writing security control information. And this is largely a paper exercise, which is kind of painful all the way around. So Project Boise came out of an incubator program that we run within 18F, and it funds internally initiated projects where most of our other work is cross-reimbursable for agencies. So we just completed our 3-month discovery phase on Project Boise, and in that time we evaluated the landscape to determine where we can provide the most value around security compliance. So 18F strongly believes in human-centered design, which means a ton of qualitative research. So we conducted over 25 interviews with a bunch of stakeholders, producing hundreds of pages of notes, talking to all sorts of groups, which you see displayed here, both from the vendor community as well as large and small agencies, oversight bodies, and within those different organizations, talking to people in all sorts of different roles, all the way from the CIO down to individual program managers. So the more people we talk to, the more we realize we could talk to, and just how vast the compliance space is. The first main takeaway we had is that no one is happy with the status quo. Software risk management is challenging and painful for all sides. At last count, there are over 4,000 pages of official documentation that relate to ATOs that theoretically you need to understand to be able to sort of complete the process. Anyone in this room who is a compliance professional forgets how hard it is to speak compliance and how hard it is for these program teams to go through these processes, which can take over a year. From, you know, I'm ready to launch my thing to, yes, you may actually launch your thing. This also adds reliance on compliance experts who don't know about the systems they're writing or assessing compliance information for. So one project of 18S, which is cloud.gov, a platform as a service, we had a contractor writing the system security plan. And after a couple of months, we realized we had to entirely throw that work out. That may have been a problem with that particular contractor, but I'm guessing the problem is more widespread. We, the federal government, have built ourselves into a corner where we need people who don't know anything about a system to describe and evaluate the security of that system, rather than the people who are closest to the system itself. So even the people that write the rules, such as NIST and OMB, are frustrated that these rules are being interpreted in a maximalist way, and that these compliance processes are done in a way where, well, if we just layer on every single layer we can think of, then we won't get in trouble. So in most agencies we talk to, improving the process isn't built into the process, so it doesn't happen. Out of that, compliance creates a culture of fear. In practice, risk management ends up being about avoiding reprisal from above rather than protecting from hackers. This creates a culture of fear and discourages taking calculated risk that might improve performance or improve the experience or effectiveness. So that culture of fear then leads to a culture of secrecy. So some agencies that we talk to during the discovery are afraid to share the compliance practices and materials with each other because they're afraid someone will find a flaw and get them in trouble. This may sound familiar to some people in this call. So just no one wants to show their dirty laundry, and it's holding this industry back. So unfortunately, that means groups can't learn from each other, meaning they don't build off one another or collaborate. So we need to get out of Word docs is another big takeaway. When working on the ATO package for cloud.gov, the system security plan template broke Google Docs and Microsoft Word. It is that big. The template itself is over 400 pages empty. That's without any information filled in. That's just the form. On top of that, we had to do things like write how our off-the-shelf logging tool fulfills various security controls, which we know has already been done in GSA and other agencies. This is not, we're using something off the shelf. So why do we need to re-explain how this handles various aspects of the security model? So being able to reuse compliance documentation for either commercial products like Docker EE or open source projects, cloud.gov, as an example, estimated that it could have saved 25% of the time they put into creating the ATO package, which is upwards of $25,000 just for that one project, that one assessment. So how can we solve that problem? There's a bunch of vendors out there that offer tools to assist with not only the infrastructure itself, but more specifically with like writing compliance information. But we haven't heard of sharing or inheritance being a key feature in any of them. So from that, we've realized that open control is the dark horse here. So Andrew talked a little bit about that format. Essentially, it's providing a structured way for control information to be expressed. So when you're using open control, the big advantage is that when you're building systems on top of others, So for example, if you're launching an application running on top of Docker EE, you shouldn't have to re-explain how Docker EE works, right? That's a known thing. And in this case, Docker providing that open control content means you can automatically inherit their security control materials. Open control and tooling on top of the open control format does that in an automated way. So as Andrew showed, expressing controls as structured data means the system security plan and other compliance materials that are required for ATO packages can just become artifacts, but you can also put it into other useful formats like the websites he showed, both that standalone one and the Docker documentation itself. So that structured data allows you to have all these different output formats generated programmatically. So Docker and GovReady and other vendors like Red Hat have seen the value of this and are leveraging open control for their products, which we're really excited about. So having just finished our 3-month discovery, we're trying to figure out what's next. There's a bunch of possible next steps, and I just listed some that we're most excited about here. So one could be building a publicly accessible library of reusable compliance content in the open control format. So for example, Docker. Docker is something that probably a lot of people use. So in this case, Docker, the company, provided compliance content for Docker EE. But what are other tools that a lot of people are using that there isn't a sort of canonical source of well flushed out compliance content, right? Security control information. So that's something that we could work on. And that would benefit all sorts of teams across the federal government as well as vendors. So another idea is providing ATO walkthrough materials for project teams. As I mentioned, most teams that go through these compliance processes have never been through them before. And so they shouldn't have to read those 4,000 pages. That is not all applicable to them. What's the sort of instructions or breakdown we can use to guide them through these materials? We have a site called Before You Ship. It's linked in these slides, which I think you'll get. And that's a guide that we use for completing ATOs within 18F, but it's been hugely useful to our project teams, and we think it's generalizable without too much effort. Another idea is checklist-based system security plans, and this is related to the next one, which is having reusable components and procedures. So in a system security plan, it gives you, traditionally, it gives you sort of open-ended text areas to describe what you're doing. While within an agency, there's very often like shared support systems or procedures and things that are inherited, by virtue of being part of that agency. And so why should I have to re-explain all of that information? Instead, couldn't we just say, yep, I'm following this incident response guide that my agency lays out. Great, I don't have to re-explain it. Check. So having those reusable components and procedures, such as I'm using our instance of Docker EE, and there's just one of them, so I don't have to re-explain what it does. You can instead think of the system security plan as, are you doing one of these pre-approved things? Great, move on. And that can make the documentation process a much smaller part of the burden. And then lastly, we're looking at improvements to the open control schema, documentation, tooling, et cetera. And presumably that work would be in support of these other sort of efforts. So anyway, I think I forgot to include the link here, but I'll add a slide. There's more information about Project Boise at boise.18f.gov. I'll send that link in chat as well.
Awesome. Thanks a ton, Aiden. Yeah, we're really excited about the premise of Project Boise, and we're eager to see what comes out of some of the next phases. And excited to be able to take a look at some of the improvements to open control and so forth. And with that, I also want to turn it over to, I think we might have Greg Allen from GovReady, fantastic partner of ours. Greg, can you hear us? And maybe talk a little bit about GovReady and how you all are using Docker and the partnership that we have with you all.
Yes, can you hear me okay?
We can, yes. Thanks, Greg.
Okay, great, fabulous. So Andrew and Aiden have done a great job of describing the idea of compliance as code. I'm going to echo some of these ideas. In essence, GovReady has taken the step of coming up with the idea of compliance apps. And the idea is that we can create a reusable, machine-readable package that encapsulates everything about how a system component such as Docker maps onto a maps onto the security controls of a compliance framework like the 853. So all the information that Andrew was describing earlier, we can put inside of a reusable package, distribute those packages much like we would distribute Docker images or other or Ansible playbooks, et cetera, and be able to show them. So it's a really cool approach. I wanted to just bring up this diagram to explain why this approach is better. The way we write security controls right now is we start with the control and we describe how the components of our system help establish that control. So we say that SC7 boundary protection is actually satisfied by the fact that we're using a Cisco ASA firewall, and we've configured that firewall in a particular way. So this is how we do it. So we have to write the controls over and over again to describe how all the different systems that we're building are using the components. In the compliance as code approach, what we do is that we actually start with the components, and we identify how the component satisfies multiple controls. And that way we can say that the Cisco, for example, the Cisco ASA firewall satisfies the IT system boundary protection by doing the following, or that Docker Trusted Registry is satisfying our configuration management. So when we do this, we can begin to imagine that every single component that makes up our IT system comes with a machine-readable set of documentation that explains the compliance controls that that component is going to contribute. When we take this approach, what we get is we now have the community, vendors, and even end users, customers, all creating compliance apps, giving us a large library of pre-written documentation regarding compliance. And what that means is that we can act instead of, what that means is that we can now, go back one slide, please. Previous slide. We can now describe the compliance of a system by simply specifying all the different components that that system needs in order to be compliant. And you can think of this like a tool drawer with a foam cutout. And the foam cutout has shape for all the different tools that we need for the particular job. But we can actually put different brands of tools or different colors of tools. We can put different tools into the foam cutouts. As long as they fit the foam cutouts, we're going to have all the tools we need for the job. And the tools that we need to make a Drupal system compliant is going to be different than the tools that we need to make Windows Network compliant. So we have these mappings. Next slide. For every single compliance app, we can describe at the top level all the components that we need, and then inside of that, we can have individual compliance apps. Those individual compliance apps can have modules, and those modules can actually take you through a short questionnaire that gathers information from the end users about the configuration or about the organization, and that information that we've gathered can then be pumped into the documentation automatically. Next slide. And that's really the quick preview of how GovReady is working with these concepts. There is a Docker version of GovReady, and it's really pretty cool. It allows you to do get up and running right away to test it out. Also describes how you can write your own compliance apps and play around with that. And we are a partner with Docker, and we're working on some workshops so we could come in and in half a day show everyone how to do compliance as code and how to do it with Docker. So we're very excited about that partnership. And Andrew, I'll pass it back to you.
Awesome. Thanks, Greg. Yeah, we're also really excited about our partnership with GovReady, and there's some great work being done to help agencies and co-deliver workshops to agencies to help kickstart some ATO automation efforts and think beyond just the Word docs and move to this compliance as code effort. So with that, we have a couple minutes for questions. We'll leave everyone with a few links and resources, including the Project Boise resource as well, boise.18f.gov that Aiden was talking about. If you want to learn more about our partnership with GovReady, feel free to reach out to us directly at compliance@docker.com. You can check out our ATO guidance on GitHub, and then also we co-authored a white paper called ATO in a Day, which talks about this whole process in a little bit more detail and how agencies are approaching the ATO and how they're getting closer to this notion of ATO in a day. It's a great blog post, a great white paper that talks about that from Nick Sinai, who was formerly at the White House as Deputy CTO. And then also you're more than welcome to sign up for Hosted Trial VE if you want to kick the tires and learn more about the stack itself. So with that, I'll turn it over to Melanie and see if we have any other questions from the attendees today.
Yep, Andrew, there is a question in the Q&A. It says the control numbers listed pertain to Docker only is applicable or covers 100% of controls for a moderate organization. Trying to understand if the SSP generator assists for Docker-specific ATO or for our organizational ATO of Docker and our apps.
Yeah, so that's a really good question, just to kind of clarify. So looking to figure out exactly what is being generated and whether or not that's satisfying the technology stack or technology components of the ATO versus the organizational components. So really we're focused on adhering to the technology components and all of the controls that are applicable to Docker EE. Now what we've written is not going to be the full complete stack, because obviously there are additional components that you as an organization may deploy, such as virtual machine infrastructure. You might deploy on top of a cloud provider or configure it in such a way that it meets your requirements. So what we've done is we've basically given you the templates and provided you with the bootstrapped project so you can fill in those blanks and duplicate that for other parts of the system that we haven't written for you. And we've also documented all of the controls up through the high baseline. So all of the controls applicable to Docker at high have been included. Now, if there are any controls that are missing, those you would have to include yourself. But with the YAML file, it's pretty easy to consume, and it's pretty easy to add additional controls into those components. And then, of course, with it being open source, it's easy to submit issues. And if there's something that we're missing or there's a typo or something, you can feel free to reach out to us through that.
Okay, that seems to be our only question, and I know we are at the end of our time here. So I will go ahead and conclude the webinar. I want to thank Andrew and Aiden and Greg for their time today, and thank you all for joining us. This does conclude the webinar. A reminder that this session was recorded and a copy will be sent out to you. So please be sure to register for upcoming Docker webinars at docker.com/webinars, and also check out docker.com/events for upcoming customer events. And again, we thank you for joining us and wish you a great day. Thank you, everyone.